The topic that we are going to cover today is resonance. So, what is resonance? It is the condition at which maximum current flows in an LCR circuit So this is known as the condition of resonance and also the frequency of resonance. So for I to be max, Z should be minimum, because we know V by I is equals to Z, that is the impedance. So for Z to be minimum, XL should be equal to XC, so that Z becomes 0. XL can be written as LW and XC can be written as CW. This is the inductance and this is the capacitance, and these two are the angular frequencies. So we can write it as W omega square is equals to 1 upon LC, and omega can be written as 1 upon under root LC. Also, omega can be written as 2 pi nu is equals to 1 upon under root LC. So we get nu is equals to 1 upon 2 pi LC, where nu is the frequency of resonance. Also, we'll just draw the graph for both of them. So the graph looks like we have I naught here and we have omega naught here. So it goes like this. So this was resonance. Also, we'll do another thing with the same, as this topic is very small. So the next one is quality factor, or which is usually known as Q factor. So what is quality factor? It defines the sharpness of resonance curve. So it is defined as the ratio of voltage across L or C to the voltage across R. So we can write Q is equals to VL or VC upon VR. This can be written as IXL if we take for the inductor upon IR. So we are left with XL upon R. We can write XL as L omega naught upon R. Continuing further, we get Q is equal to 1 upon R under root 1 upon L C. As we already find out that we took R outside, that L upon omega C. Let's go a bit above and see what we did before. We saw that omega is equals to 1 upon under root LC. omega is equals to 1 upon under root LC, and we also took this L inside. So we get Q is equals to 1 upon R L square by LC. We just multiplied L square here. No, actually, I just did a mistake. This is L. We left L upon R outside and we wrote, as we know, omega is equal to 1 upon under root LC. Now we take the L inside as L square and these two get cancelled. So we get Q is equal to 1 upon R under root L upon C. So this is our resonance factor. Also, if we take the voltage across capacitance, we'll get the same answer. We take Q is equals to VC upon VR. So we are left with XC upon R. So we can write it as 1 upon R into 1 upon C omega. So we take 1 upon RC out and we under root LC. So we get Q is equals to 1 upon R LC by C square, and we get the answer as 1 upon R L by C. And these two are exactly the same. So we can take the voltage across capacitor or across inductor, we get the same answer. Also, we have a graph for resonance. That is a very important graph. That is this. So we have I naught by root 2 here, and we have the angular frequency here. So the curve basically moves like this. This is the curve between I naught by 2 and between the angular frequency. So thank you, and I'll see you in the next video.